Hi, Professor. Let me show you my assignment to project the mushroom cultivation with AWS code. It comes with 5 parts, and now let's begin with the first part, problem statements and solution usage scenarios. As a high-demand agriculture active, mushroom cultivations it requires precise temperatures and humidity levels to be maintained throughout the growing process. However, traditional monitoring methods are labor-intensive and error-prone, while manual control of the mushroom growing environment often leads to poor growing conditions. Therefore, there is an urgent need to process a technological solution that can monitor temperature and humidity in the mushroom growing environment in real time and enable process control of these critical factors through an automated system. This solution has the following practical application scenarios. First, the real-time monitoring features enable growers to continuously monitor temperature and humidity, receive timely alerts, and take protective measures to maintain conditions for mushroom growth. This means that growers can better understand the changes in the growing environment and make timely adjustments to temperature and humidity to optimize growing conditions. Second, the remote management of data allows stakeholders to remotely manage the growing environment, access real-time data, and receive alerts through a web-based dashboard or mobile app. This allows stakeholders such as growers or the farm managers to monitor the growing environment anytime, anywhere, and make timely adjustments and decisions to improve productivity and management. Additionally, historical data stored in the cloud can be used to tend analyze protective maintenance and decision-making related to optimizing growing conditions and increasing overall yields. This data analysis can help growers develop more scientific growing strategies, while providing decisions makers with data and help them make more informed management decisions. Finally, the system can also be used to ensure compliance with regulatory requirements for mushroom growing, providing a reliable record for environmental conditions throughout the growing cycle. Part 2 is the concept. My system employs a multi-tier agriculture that includes 4 layers. The first layer is perception layer, which is monitoring temperature and the humidity using sense head sensors. Then is the network transport layer, utilizing a Raspberry Pi as a gateway device to transmit data to the cloud platform. And then is the core layer, which is at AWS cloud platform encompassing services like AWS IoT Core and DynamoDB for data storage, analysis, and processing. And then is an application layer, which is delivering real-time data display and user interactions through an HTML interface. The third part is solution design. When the sense height sensor collects temperature and humidity data, the data is sent through the Raspberry Pi gateway to the AWS IoT core. After it receives the data, and then it triggered a Lambda function to add data to the DynamoDB database to storage the data. Then use another Lambda function to analyze the data in the DynamoDB database and return the data and message to the AWS API gateway. Finally, the temperature and humidity message will display in real time on the client HTML interface. This interaction enables a seamless flow of data from the IoT device to the cloud and back to the client, allowing users to easily review environmental data and stay up to date with the information they need. In addition, the system is able to accommodate growing data volumes and user needs. And let's go to the part 4, implementation steps and code description. This following Python code is used to parse temperature and humidity data from sensor, and the time and some message to the shadow of the XY scene in AWS. This line is initialize the shadow client, and here is configure endpoints, and this line is configure certificate. The data and the message will show on the shadow like this. The best temperature is for the mushroom grown is 14 degree and to 34 degree. The best humidity is 18 to 85. So if the temperature and the humidity like this, and the shadow will display the message great environment. Then create a lambda function to process the data in the shadow and store it in a table called environment in DynamoDB. The code is like this. And the table in DynamoDB is like this. And then create another lambda function to process the data in DynamoDB to display it to the AWS API gateway. And finally, the users will see the information from the web page like this. Now let's go to the demo.
This is the Python code, and I use this code to send the temperature, humidity data, and environment message to the AWS A2 core shadow. Let's run it. I set the temperature at 60 and humidity at 83. Let's refresh the shadow, and we can see the data at here. It's a great environment. And now we can see the data on the web page, like this.
Let's go to the final part 5, innovation and future work. The originality and creativity of the solution is that first is integration. The Raspberry Pi and the sense height sensors connect real-world data to DynamoDB through AWS IoT Core, Blend IoT Core, IoT, and Cloud for monitoring and analyze. And second is real-time display. Lambda retrieves data for instant viewing on an HTML interface, offering users immediate access to temperature and humidity data from anywhere. And this is through thoughtfulness of processed future improvements. And I think in the future, I will optimize data transmission and storage, enhance data analysis and application functions, improve user experience and interface design. That's all. Thank you.